Hello, everyone. Good evening. My name is Cor Schmidt. I'm an IEEE PES volunteer here in Region 1-7. And today we're doing another podcast of our activities. And today we have the great honor to receive here Mary Reidy. And she's a great volunteer in IEEE in PS, as well as a great professional in the power system career with an extensive CV. And the main idea of our session today is to have like a conversation, a chat, as we had in another ones, with great professionals, where all the attendees and the panelists they have opportunity to make questions, to assign some curiosity that they have about the career, what they can do right to have this successful career, some tips and some advices to make this path like easier. Then could because we know that can be really hard to have a successful career in the power systems. So we try to have this podcast to get this conversation closer with these great professionals, just to understand and get some tips and advice to make our path easier. So today we have Mary Reidy, and we have the great pleasure to have her here. I'm going to start with a quick introduction. We know like she has a really big, extensive CV, a lot of activities and volunteering, but we are going to just highlight here some points. After that, we have she's going to do a quick introduction, and then we are going to start with the main questions. So we have a few questions here, and then the attendees can also bring some questions, some curiosity that they have, and we can get like a more engaged conversation. So Mary Reidy has over 30 years of experience in working electrical and gas utility, with the majority of her experience based on managing the largest commercial and industrial customers. In addition, she has worked in the Smart Grid Technology Lab, part of the team that proactively investigated an end-to-end proof of concept of approach that would integrate two-way communication between sensors on the utility distribution, transmission, and control center operations. She was responsible for responding to an Obama administration RAR grant focus on both internal utility workforce management across 19 job categories and developing a proposal like in 6 upstate New York University and National Grid in a utility academic program that would provide educational path for students to be smart grid degree program at the associate to the PhD level. National Grid has awarded both ARR grants. She was also Secretary, Vice Chair, Chair of the IEEE P1809, which became P2030. As Chair of the P2030, she managed over 250 worldwide volunteers, and she presented a draft standard for consideration to IEEE. Currently, she's a member of the New York's Clean Energy Climate Change Initiative and actively participates in the energy intensive trade exposed working group. She holds advanced degrees in business and engineering, bachelor's degree in electrical engineering, master engineering, bachelor's accounting, MBA, as well a doctorate in management, economics, and public policy, and have a New York professional engineering. So thank you very much, Mary. I really appreciate your time and to be part of this podcast. We are extremely grateful for your presence here today. And just to start with a few conversations, I'd like to invite you to just briefly tell us how was your path in the since the undergrad until like a professional life. How did you engage it with the National Grid? Just like a quick, so we can have like a better understanding about your path in the power systems field.
Thanks very much, Hazawa, and thank you so much for the introduction to the PES community, both in U.S. and Canada. It's wonderful to see this level of attendance at after dinner. So just briefly, I started my career actually in the STEM field. I have to give credit to a wonderful professor in undergrad who encouraged me to continue to take more math classes. And he had just such a dynamic way of teaching, just a wonderful way to explain, very complex concepts. And then during his lecture, he would actually bring in an example of how you might use, for example, limits or differential equations. And it just really sparked my interest. And so I continued in that field. And then upon graduation, I interviewed for many different positions and was very fortunate to join the utility industry. And so I've been able to navigate some wonderful opportunities throughout just a few years, right? But no, I really enjoyed it. And I think in summary, what I'd like to leave with the audience with is uh, if you were to look at, if I were to look back at my career, I think it's fair to say that I moved in many different areas. So I never was a design engineer. In fact, I thought when I started my career, that's really where I wanted to be, and spoke to vice president, and vice president said, you know, what I really need is some folks to be able to engage the large commercial and industrial customers. So if there are questions on that, I'm happy to answer them. And I think I'll just kind of open it up here, Hasala, for the next point or next question.
It's perfect.
Conrad, can I add something?
Definitely.
So how did you get into STEM field? So this is something that I'm um, always interested about learning. Like, how did you get into the STEM field? What was the motivator for you?
So from an early age, I grew up in a large family. So there was certainly, you know, constraints on resources. And so, you know, in order to solve a lot of those problems, you had to really kind of sit back and think about how you would actually solve a problem with limited resources. And then when I went to school, I had the advantage of, even in elementary school, I had some very, very strong math teachers that could teach math in a way that you really wanted to absorb more of it. And I continued that path, and I credit those early, you know, early experiences with math and with science, with physics, as being a way for me to really start to understand the concept, look for uh, more and more knowledge in that area. And then when I went to college, I originally was looking at pre-law school, and I had some wonderful math instructors, math professors that encouraged me to take the next math class. And in many cases, I would say to them, I don't need this math class for my requirement. I'm going, you know, pre-law. And they said, well, you really need to take the next math class. And it was really a credit to a lot of those professors and the way in which they taught the material that really changed my mind and redirected me into STEM.
Thank you, Mary. Conrad, let me add something to all our participants here. Guys, this is your opportunity to pick the brains of all the people who come to this sessions, our podcast. And so it is your chance to ask questions. So if you do have a question to ask, we can make you a panelist. But what you need to do is either put it in the chat box. But I personally would prefer if you would raise your hand, which is on the participants tab. There is a raise hand tab or button. Just press on that, and our folks here will raise you up to be a panelist. And if you can put on your video, you can just use your audio and just interact with the folks here. So that is what we want. But if you're shy or if you don't have those facilities, feel free to put your questions in the Q&A box. But this is not about us. This is about you. So you take priority over the questions that we have. So feel free. Over to you, Conrad.
Perfect. Thank you very much. So a good comment. So everyone, just feel free to drop your questions and join the conversation here. I personally have one question for Mary here. I saw in your CV that you have like a lot of experience in management, soft skills for the company, and we know that like nowadays engineering is not related about only technical stuff, but more in the how to engage with people and how to lead some teams. So I'd like to check to know from your side, when did you see that these soft skills were so important for your career? When did you actually observe that, oh, I need to get better in these management skills and not only my technical side?
Thank you for the question, Conrad. That's excellent. One of the very first assignments that I had was working with the large commercial industrial customers. And what that meant was I needed to go out and tour their plant. And as part of that, I really needed to understand what their business issues were. And so many times I was dealing with the plant engineer. And then because it had to do with business, you know, where was the business going? What did the business see as concerns? What questions did they have of me as a representative of the utility? Many times I would be asked to join in a meeting with the plant manager and the plant controller. So you had the technical person and you had the finance person. And both disciplines have very specialized needs, right? The finance person is looking at profitability and cost and you know, how do we use those resources efficiently? And the plant engineer is looking at things like, how does the plant run? How many machines do I have going at any one point in time? What's my shift schedule? How many workers do I need to run this particular shift? What's the next level of technology that I need to look at in terms of my plant operating efficiently? And I became fascinated at having those discussions with both sides of the business. It just really enjoyed it. And the more I started to listen to the conversations, the more I learned that I need to really understand what their needs are because I represent the utility. I need to go back to my company and make sure that I can share those questions with the right experts. I think one of the things that we all learn that when we come out of college, we have this vast amount of knowledge and now we want to apply it. And once we go to the business, we realize that there are similar disciplines, whether they be accounting or law or economics or marketing, and they all have very different skills, but we're all trying to solve a problem, and that is, what does the customer need? How do we understand it best? And then how do we work together so that we can provide a couple of options for the customer? And once we come to that understanding, then it's up to somebody like myself to go back and sit down with the plant manager and the plant controller and say, based on the conversation that we've had, here's a couple of options I'd like to discuss with you, and then to further refine what the customer's really looking at. And so it becomes a cycle of conversations. That to me was a really wonderful example of the importance of not only understanding the technical side, but also being able to communicate it very well to the people back at the utility with very different backgrounds, and then to understand and listen to what they're saying to me so that I could go back and share that information with my customer in a way that I was either getting validation that yes, in fact, this was something the customer would consider, or I was also getting information that said, well, that's close, but after thinking about it, we want to talk to you about a different option. So all of those discussions really got into, as you mentioned, Conrad, more the soft skills. It is the communications piece of it, but I think it's something that not only was it needed when I started out, but I think the enjoyment for the engineers is just enormous. And I've seen wonderful engineers with great communication skills. So I hope I'm helping to answer the question, but please ask me if it sparks some interest. Hasala.
Question.
Go ahead, Hassan.
Yes. Thank you, Mary. So in a broader context, when I look at what you have done, what in the industry, it just kind of looks like you have really positioned yourself for success and really looked at developing yourself into a really good product. You have a Bachelor of Science in Electrical Engineering, you have a Master's in Engineering, you have a Bachelor's of Science in Accounting, a Master's in Business Administration, you have a doctorate in Management. So what was your thought process? Because in our careers, when we are done with our bachelor's, we are like, we're never going to the university again. Most of us are, or quite a bit of us are like that, because it's pretty hardcore, right? I mean, going through the engineering degree. But what was your thought process behind getting all these knowledge? How did you position yourself? And is there anything that we can take away from what you set up in your career?
Oh, thank you for the question, and thank you for the very kind words. My short answer is to say lots of tuition bills to repay, right? And lots of late nights. So don't look too closely. I got lots of bags under my eyes. I'm just that's my short answer. But seriously, I think for me, when I came into the industry, I really had sort of that wonderment. I knew a part of the business, or I thought that I had a fundamental understanding of it. But as I started to go to meetings, whether they be with the customer or if I was sitting down with one of our really expert senior level design engineers, as they would talk, I would start to think about other questions. And then I realized there was a part of the discussion that I understood. And then there was another part that really intrigued me. And I thought that would be very interesting if I learned more about it. So I would either, go to the IEEE meetings and learn from, some of the lectures or some of the conferences. That was one option. I was very active with IEEE as a student member. I was an officer in the student chapter, but I think for me it really was an issue of I really like to understand more, and even now I would say to you I'm asking myself that question about I know that there are changes coming up in the industry. I'm seeing some of them, and it's almost as if you're seeing like little pebbles in a pond, and that there are other pebbles in the pond, but they may be deep underwater and you can't see them, but you're curious and you say, I wonder what it looks like. Are they clustered? Are they spread in an even pattern? Why did nature put them that way, and how does it actually add to the balance of the pond? So if I can kind of extrapolate that analogy and say, we see the energy industry, we see some of the changes, both in terms of technology and in terms of the customers that the utility serves. Lots of discussion about, what types of technology, how do we add data? I know that certainly in the university right now, we're talking about artificial intelligence, talking about robotics, and we're seeing some of that in the energy industry. My company happens to be working with one of the firms out of Massachusetts to put in some robotic, what they call Spot the Dog. And Spot the Dog actually moves around our outdoor substation to do conduct thermal measurements on equipment that may be, would be considered a little bit rough for a human to do. We have technology that actually goes into our gas pipeline, and it's robotic technology, and it actually has a camera on the one end of it, and it's used to look at the integrity of the welding, so that we're doing some predictive analysis. So there's an immense amount of data. It's out there for us to use, and now it's a wonderful environment, especially with your university classes. I'm going to actually kind of push back and say to you, where do you think that technology might be applied? How do you think we might solve additional problems? Because I think one of the fundamental factors that moves us as engineers is that we're solving problems for the benefit of an individual. Ultimately, we want to make people's lives better, increase their quality, better systems. So now we look at our energy industry and we say, we've got renewables coming in, we've got technology in terms of data, we've got modeling, we've got new systems that are going to be ways in which we can look at the whole infrastructure in a different way. To me, that's a fascinating environment to be in. And I think it really speaks to the fact that all those things that drive us as engineers, that curiosity, that creativity, the idea of, if there's a complex problem, we're really kind of drawn to that. And we want to look into it and say, that's interesting. For me, working in the industry, I have a lot of questions that I know, honestly, I'm going to run out of time to be able to solve. And so my goal is to be able to bundle up those questions and pass them on to folks like yourself and say, this is what inspired me. Here's the questions that are now surfacing. I need to give them to you, and I wish you the same type of excitement. That basis for that visualization of that question came about as a result of a lecture I heard the astrophysicist Neil deGrasse Tyson mention it at a lecture in Syracuse, New York. And I thought that was fascinating. And I think that really defines us as engineers.
Go ahead,
Yeah,
Clinton.
thank you. That kind of got me thinking, if you could snap your fingers and make one technological solution happen with none of the logistical considerations, if you could just magically make a solution happen, a technological one, A, and then a regulatory one, B, if you could magically make a regulatory change today, what would those two things be?
It's an excellent question, Clinton. Thank you so much. I feel like the purpose of setting this podcast is really being satisfied, because what we're talking about now is encouraging more questions. So I think both of your questions on the technology side and the regulatory side, I think I can frame in a similar type of format. As we see the use of technology, use of data, the use of computers and information systems, and some of the things we talked about with smart grid, smart cities, adding more data to our everyday lives. I think it really helps to encourage folks that may have felt as if they were struggling with how to understand what was happening, and then to really get their questions addressed in a professional way. So why do I say that? Both from a regulatory standpoint and from a technology standpoint, they really overlap with the needs of the customer, right? So we see all these changes that have happened in the industry for many years. Many times you can actually chart the path that it's in response to an unmet customer need. So why do we say that we need to have the regulatory part in this? Because the industry really is a regulated monopoly for efficiency standpoint. Okay, that's the design piece. The practical aspect is, if it's a regulated monopoly, what it says is within that particular geography, that particular utility agrees to serve every customer that's in that geographic location. Okay, so that's the theory. What's the practical aspect of it? When you say every customer, that includes your most sophisticated industrial customer. It includes all of the residential customers, and it also within the within the residential customer class, it includes the residential customers that have a sophisticated level of knowledge, and it also includes those customers that are really underrepresented, that are economically struggling. So now, why would we look at it that way? Because the solutions that we're going to try, we meaning all of us as engineers, are going to try to solve going forward in the energy space, especially if we're talking about the regulated monopoly, we need to take a look at all the customers that are impacted and say, I can't provide a solution for only one type of customer. I have to provide a solution that works for everybody. So let me give you a specific example. When I was working in the smart grid lab, on the residential side, I had the opportunity to speak to quite a lot of customer groups. And my question to the residential customers, after I explained what we were trying to do with smart grid, went something like this. How many folks are interested, excited about smart grid? You have your iPhone, you have some smart technologies. And most people said, oh, I love that technology. Second question, if we were to invest in smart grid technology, what would you be willing to pay incrementally in a month? So what I heard from them was, a lot of thought, a lot of smiling, and then the brave customers raised their hand and said, well, I'm not willing to pay anything. It should be free. So now we come back to our situation of like framing the problem. So we might have great solutions and say, you know, I have the best technology that's going to solve this problem, but it's very limited in terms of how do I actually deploy it? Because in order to do that, I'm really talking about adding more cost that really would be unreasonable for those that are financially stretched. I'm sorry if I spent too long answering that question, but
No, that was great. That was great because you gave an answer that shows kind of what it really means over the decades that you've seen how things shake out. It's not just that an engineer comes up with a solution. It's that the solution is viable and long-term sustainable, and that's the real truth. Thank you.
you're welcome.
Go ahead.
I have a question as well. So circling back to the time where when you were an undergrad, I just have a question about what field or specialty in power engineering would you recommend for someone whose goal is to work at, say, like yourself at National Grid's Control Center?
That's an excellent question. I think in terms of the time frame that I made my choice, and the time frame now may have changed the discipline within the engineering area. I think on a control center perspective, during the last, I would say about a year ago, when all of the world was going through management of the pandemic, my firm actually went to our control center and talked to our folks, and they decided to sequester the folks that worked at the control center for several weeks. And so what did that mean? That meant that the individuals were away from their family. We had portable laundry mats come in. We had catering come in, and then we had cots come in for, to provide the comfort and the rest for the employees. So what were the employees really doing? Yes, they were looking at the overall system and making sure things were operating the way that they were intended. I think when we were talking about what you're all studying now in terms of university programs, um, certainly we know what the control center systems are all about now. I'm going to push back and challenge everybody that's looking at those areas to think about what types of advances would technology likely present for somebody who is a control center operator? What kinds of things would they look at that would help them do their job? Let's frame it in terms of what's happened over the last several years in terms of very unusual weather events. I'm going to ask you about, I'm just going to ask you to go with me down this path for a minute. We at my company have brought in a gentleman who actually used to teach classes on small unmanned aerial systems, also known as drones these days. And so one of the things that we're doing in that space is to look at developing use cases for environmental weather events, sort of predictive analysis. So if we have one of those storms, a flood, I live in Syracuse, so we're in the Northeast, so we have to be concerned about winter snow events. If we have those blizzards, the question is, when they happen, are the access to those facilities available? Could we use drones to see what's happening? Could we use drones to actually look at things like environment? Do we have endangered species that like to build nests on top of the distribution cross arms? That to me, if you deploy the drone, where's the next level of development? Well, the drone is doing what? It's collecting data. So you bring back all of the data. Now with your university studies, you have systems, you have ways to actually interpret the data to provide some predictive cases, to provide a better response time. When you have a storm, what you want to do is make sure that you get any of the customers that are affected by the storm back and surface as soon as possible. What if you use the technology and your knowledge of data to be able to help the folks that are actually working on the infrastructure know what the system looks like? So better situational awareness. I'm hoping that I'm answering your question. I think, with the knowledge that you have at the university on some of these modeling programs, what I would say to you is this is a wonderful environment to really start thinking about what does the data really say? Why am I collecting it? What model am I going to use? And for what purpose? Because you don't want to get into a point of saying, I can collect all this data almost real time. And so now you have a mountain of data and you're underneath it. And now the data is driving you versus you really want to be able to say, maybe I don't need constant data. Maybe really what I want to know is these particular data points at this particular time, because my model is going to do something that's going to, again, what's the ultimate purpose? We want to improve the lives of people. So how do you do that? So you want to kind of start with the end, the end goal in mind. And I think it's just, I think it's a great time to be in the industry.
So
Yeah,
to
I
add,
think yeah,
so
go ahead.
Mary, just to add to what you said. So what you're saying is that if you want to go out there to the control center, it's rather than focusing on the power system, what probably would give you that edge would be things that are cross-disciplinary, right? Like things that maybe conventional power system folks might not be experts at, right? Like how you analyze data, how AI. So that would probably position you in a really good place. That's what I got from what you said.
I think that's a great point, Hasala, because I think, at least in my experience, what I found to be the most exciting and most rewarding is to be able to look at a problem from multiple ends. So the first thing I always recognize is I'm not the expert. I was focused in my career mostly on customer issues, metrics, trying to develop programs that would, again, help to connect folks with different backgrounds. So with that in mind, the question then becomes, I need to rely on certain experts. So when I sit down, I'm having a conversation about what's really the purpose of me asking somebody to give me their time. I'm asking maybe somebody from a particular discipline. Here's the issue that my customer is raising. You have the expertise. I can provide the knowledge from this particular avenue, and then together we can work on a potential solution. When I talk to this individual may say, this is intriguing, let me bring in a few more folks from other disciplines in the company. And then you sit down and imagine the type of solution that you have in front of you when you've got 3 or 4 different disciplines. So to your point, Hasala, it really is a wonderful opportunity to be able to meet with people that have been trained in different areas and say, here's what we think our common problem is, but let's start talking to each other.
I have a question here. So Mary, like in the industry perspective, how do you actually find a solution for a problem? We always are figuring like a lot of problems and we need to come with a solution. So how you organize to come with this solution for your design problem?
Shall we use some slides? I think maybe you want to use the slides that you had sent us, Mary.
Sounds great. Can I, Conrad, should I stop my video so we can just get a better quality on the slides?
Yeah, no, I can share here. I think you can keep your camera and I
Okay.
can share my screen here, okay?
Sounds great.
I just need to be the presenter.
Yes, sir. See, Conrad's gonna be my tech subject matter expert for this next part.
No, we are here to help. These are new times. We need to learn a lot of new stuffs. But that's good because with like all this COVID, at least we could like get more people together. We can meet new people. Everyone's so familiar now with these virtual meetings. So that's a good point. Okay, let me share my screen here. Can you see the slides?
Yes, I can. Thank you so much.
Perfect.
So I have to call out Conrad and Hasala because both of them were my inspiration for putting together the next few slides. And the reason why I say that is we were talking about my perspective. Again, it's my perspective, so feel free to challenge me on it. But really what we were talking about is what would be most interesting to our group here with the podcast. And so what I wanted to do is to just share a couple of thoughts for you, and then I'd love to get your feedback. And if we have time, I can certainly share, what I've seen over my career in terms of changes in the industry. But it depends on. I'd like to hear your questions first. So we'll start out with I saw a really great article, and I referenced it there at the bottom of the slide. And I really started to think about it, and I wanted to add just a few points to it. And so where I was headed with this is I wanted folks to think about, we've all decided now we wanted to be engineers. And so let's step back and say, why did we decide we wanted to be engineers? So we talked about, well, we really like to solve complex problems. If something is out there and people say, gee, that's interesting, or we happen to see an event, I think it's pretty clear that quite a few of us will say, not so much, isn't that a wonderful event? But the second question, why did that happen? What was going on to make that happen? And then the other piece of it, I think many times we find ourselves in situations where there's just a problem, and we look at it and we say, I can make that person's life better if I think about things in a different way. So in my view, we really have two what I call drivers that help to support us as engineers. One is an external driver and one is an internal driver. So let's do the internal ones first. Again, based on the article calls out, 5 elements, and they say that the engineers have a natural curiosity, have a creative spirit, are good critical thinkers, have a collaborative spirit on the external side. They are effective communicators, meaning they communicate well with others, so it's external. And I've added the last one, which is a social need, because I think above everything, what we do really is not not something that we do for ourselves individually, but it really has an impact on society. And so those are kind of the balanced approach that I see in terms of our original awareness that kind of drove us into this field of engineering. So if I can have the next slide, please, Conrad. So we'll just a few slides. We'll move through the rest of them pretty quickly. So we were talking about earlier on in the discussion, really looking at complex systems. And so I'm going to challenge folks here, and I'm going to ask you, when you're presented with a complex system, to step back after you've thought about it for a little bit and ask yourselves, why am I taking on this challenge? What's my purpose? What's the output? What types of systems or processes do I think I'm going to need to help me work through solving the problem? And then what's the timing? So when do I expect it to be done? And in simple format, probably apologies to the electrical engineers. This is more of a mechanical engineering visual, right, with the gears, but I just thought it was a really good one, because think of all of the gears in motion. So the question is, why are we doing it? Then how are we doing it? How are we actually going to approach the solution? And then timing is always important, right? Because if we have a problem that we want to solve and it needs to be solved within the next week and our solution doesn't come out for 6 months, we've really missed that opportunity. So next slide, please, Conrad. So this I want to speak really to the point that that Conrad and Hasel and I talked about originally, which was to look at sort of look back on my time in the energy industry. There have been quite a few changes. We started when I entered the field with really, in many cases, a regulated monopoly that was a closed system. And what do I mean by that? A lot of times the utilities own their generation, they own their transmission, they own their distribution systems, they serve their customers, and it was one entity with, you know, the entire system under their control. If you look at it in 2021 and 2021 plus, meaning going forward, we have a system with many owners. We have generation being owned by multiple folks, multiple owners. They could be locational based, they could be technology based, they could be internationally based, but they all bring a certain expertise to the table. On the transmission and distribution system, many times you'll see the regulated utility in that space. On the customer side, in terms of the relationship with the customer, in some cases, that some of those transactions are actually being managed by firms that work for the utility. So then the question often becomes, well, if there's all of these ownership changes within the industry, how do you create that essential component? And that's where we're going to start seeing the important part. And the important part is the recognition that none of us can do everything ourselves. We really need that discipline of being able to say, we have experts in this field, we have experts in a second field, and our challenge or opportunity at this point is to create an environment where everybody feels comfortable coming together and saying, here's what we think the problem is, and be open to really kind of challenge the assumptions about the problem, have the conversation, define it, crystallize it, and then continue to bring the stakeholders into the conversation so that we're all helping to develop that solution. Next slide, please, Conrad. There's only two more. The fourth one really speaks to the last comment that I made with slide 3. Once we solve that problem, we feel really good about it. So we've identified the need, we have a potential solution out there, and then what happens? Usually, if we're providing the solution to a customer, the customer says, "That's really great. By the way, can you do can you solve this other problem for us?" So maybe what we do is we look at this really as, you know, widening circles. We provide the solution for the first need, and now we monitor that. Development occurs, customer gets intrigued by the solution and says, "Wow, that's fantastic. By the way, I have another problem. Can you help me with that?" And so now you're drawn back, and the conversation just continues. And so now your knowledge builds, and then you get a chance to work with more people, more subject matter experts, and you just keep building on that. So your knowledge increases, your wonderment increases, and your potential to create more complex solutions increases. And the last step, the last slide, please, Conrad. So where's this all going? It was this is a question that Sala had asked me, you know, where could I actually see how I could maybe provide some thought for you. I think one of the things that's worked for me is I continue to be curious. I continue to think that I start out with a few problems, and then I go forward and try to provide the solution. And what happens is I tend to then look back at my notes and realize, yes, maybe I have grown in this type of information, but now I have 5 more questions. And so I find that extremely exciting. I like that idea that, you know, once you solve a problem, there's another one that comes to surface. Do you have something that you've worked on that you could actually enrich your decision making on the second problem? And if so, great. That's a wonderful opportunity. If not, you know you've built some relationships, you've used your soft skills, you have people that you can rely on for input, you refine the problem, you identify an emerging need, and then you're prepared to continue again and use that process all over again. So hopefully that provides some encouragement for you, but I'd love to get your questions. And if you disagree with me, I'd love to hear your disagreement as well.
Go ahead, please.
Hello. So Mary, I have a bit of a question. But first, I would like to say that I admire your the curiosity that you still have after years of being in the field. I think that's great.
Thank
And
you so
then,
much.
You're cutting out.
I think I am. I'm sorry, can you hear me now?
Yeah.
Am I good now? Oh, okay. I seem to be getting it like a bit of a delay here. Okay, I think I'm okay now. Do you foresee a necessity to increase the number of HVDC transmission lines in the future, being with like all the other renewable resources that are being integrated constantly in the grid? And if yes, what are some of the challenges that implementing the HVDC transmission lines would bring, in your opinion?
It's a wonderful question. Oh, sorry, I was hearing some feedback. So are you from the Canadian section?
Yes, I am.
I thought so. So just for the folks that may not be aware, there are some HVDC projects that are going on or existing, and some actually I think are in the middle of the project between the US and Canada. So the question is a really good one. I think certainly it's existing in an environment where a lot of things are changing. Technology is changing. We talked about that. Talked about certainly information, data and analytics, prediction. The other thing we also have to go back to is this concept of where's the growth? Where is the to use an industry term, where's the demand for energy? And so a lot of times in the past, when I first started, you could certainly look at your geographic region and you knew where your customers were. So you knew where your demand was, where your load was in many cases. And when I started, a lot of that, was pretty, what you would say, pretty known, pretty stable. Customers were in those locations because they either started the business, a lot of their employees were local. Why do I mention that? So now we fast forward to 2021, and we're seeing a lot of mobility. We're seeing a lot of changes in terms of ownership of industries, not necessarily local employees. Certainly, with a global economy, your workforce tends to be mobile. And the other piece of it is the change in the type of technology. So we talked about, renewables. What else are we talking about these days? We're talking about smart cities, smart grids, smart communities. We're talking about solar. We're talking about even smaller community-based renewable energies. In addition to that, in some communities, we're talking about microgrids. So I'm not directly answering your question, but I think it's more important to sort of get that feel for, let's define the problem, or let's define the need is probably a better term for it. So I think one of the things I would encourage is to have a discussion, or to watch, if this isn't your project, if you're just curious about the technology, take a look at what's happening to that technology compared to other technologies. One resource is the IEEE PES Society, certainly the publications that are put out, because the advantage of looking at some of those publications is you'll start to see a lot of the papers that are presented, and they're talking about, the existing geographical area, what's changing in the geographical area. You may want to look at local news for, are businesses coming in? Are they stating that they're happy with the environment? Is reliability important to them? Are there other concerns that they're talking about publicly that you could use to kind of help to frame what's happening in the environment? And then it helps you to understand, is this technology, a leading technology? What are the strengths of it? What are the weaknesses? What are the alternatives? So I'm sorry, I can't, if I could predict things, I'd be in a different field, but
Oh yeah, no, that's totally perfect. That was great. Thank you.
I have a question, Mary. Like speaking about these solutions, we see that we have a lot of technology. We have new algorithms, optimization to have like a better grid. But sometimes we observe that the utility are still a little bit afraid to implement some of the new technologies. So do you think that what the utility is afraid more because about the money, because it's really expensive to implement them, or is more because the mindset, we have like an old mindset, the utilities they don't want to change the traditional way? What do you think about that?
I think it's a wonderful question. A lot of the questions I get really are around this area. I think one of the things that are really important in terms of understanding the rate of change or the rate of technology adoption is to let's sort of what I call pull back the lens a little bit and say, I'll give you an example. When I first started, we were talking about, more of a closed system. And so why did that happen? Well, I hate to go back this far, and just for everybody's reference, I wasn't alive during this period that I'm going to speak of. But 100 years ago, we had three gentlemen, right? We had Tesla, we had Westinghouse, and we had Edison. And so what were they challenged with? They're looking at this and they're saying, well, I've got an idea on how I can actually take electricity or take power and actually allow it to move long distances. Well, that's interesting. A lot of customers weren't the first adopters. You had certainly some investors that were looking at it, but it was a concept. And so now what happened is you test that concept and you move forward. So then there were challengers about, well, should it be DC? Should it be AC? Should it start with street lights? I always like to say I was so happy to start in Buffalo because Tesla's area was in Niagara Falls, which is about 45 minutes northwest of Buffalo. Yeah, I have to be careful because too far west goes into the lake. But you look at that environment, and that was really exciting. So now you fast forward it and you say, where are we now? And why was it put in place this way? Why do we actually go to a regulated monopoly model? Well, it was really to prevent, inefficiency of having overlapping wires and, poles on one particular street to serve, customers. So with that in mind, one of the things that we want to look at now is we know what our situation is today. It's really hard to predict what's going to happen next year. I mean, we look at what we just went through in the last 18 months or so. So it's an unknown. And it makes it I'm sorry, I didn't fully answer your question. It makes it difficult for a firm, or I should say an industry, that is designed to really look at a particular area and say, here's all the elements that are within this design platform. All the customers are located in this particular area. This is what we need to design for. You design for that, and then you serve the customers, and the customers say, again, remember we talked about residential customers, you've got to be fair to everybody. Now, if you want to change that, what does that look like? And it really has to be very thoughtful, and we have to make sure that we're doing it well, that it continues to serve everyone.
Perfect. Thank you very much. We have a question from Julie. I just ask for the host to unmute her.
Oh, great. Thank you. I want to piggyback a little bit on the last question, but from a slightly different angle. I feel like the power and energy sector of electrical engineering has sort of operated, I don't want to say in the dark, that would be a terrible bad pun, but not necessarily in public light in the way that's like civil engineers or traffic engineers. When they want to do anything, they have to have a big public meeting. But people are voting with their feet and putting panels on their roofs and talking about microgrids in terms of, larger institutions, whether they're hospitals or universities. And I feel like that's bringing power systems to need a public face. And I was encouraged when you talked about having public meetings about the smart grid. And my question is also a little informed by living in Chicago during the heat wave that took down ComEd and 1,000 people died, which in the United States is a pretty substantial scale. And I'm wondering how we can go about, as electrical engineers, working on that public face so that we understand that some of our customers are not only savvy, they are in fact distributed resource generators, and drive lots of changes that need to make that work. So it's either dispatchable or aggregatable and partially dispatchable. I mean, that it's a real hornet's nest, but I feel like we've got to address that, because otherwise people who are very tech savvy, very integrated with other kinds of, data and requirements are gonna, they're gonna, start burning it down, and it also frankly has the possibility of reducing problems in areas that tend to be poor, where the grid is so weak and are the first places to go down when, say, a hurricane hits Cleveland, Ohio, which happened a few years ago, So, Hurricane Sandy hit all of the eastern half of the United States. So I'm not exactly sure what the question is there, but I feel like maybe it's, how do we make a space as electrical engineers to be that public face for power systems going forward?
I really love your question on multiple fronts, because I think primarily the folks that we've brought together as part of this podcast, and credit to Hasala and Conrad for initiating it. I really would encourage the IEEE PES to start thinking about some of the societal questions, some of the technologies. And I think that, we as a group have an opportunity to start talking about who we are as engineers. If we're power engineers, what does that mean? How can we engage the what we call stakeholders, but the community that we all live in? Because you're absolutely right. A lot of the technologies that we're talking about, we're comfortable with it. When we talk about microgrids, or we talk about data, or we talk about sensors, that makes us very excited, and we're thinking about how we can actually deploy all of them. Outside our particular area of conversation, I really think that there's a huge opportunity to start to engage the community and say, we were talking about this particular change. Here's some of the thoughts that we have. Now, I'm sorry, was that Judy that asked the question? Julie?
Yes. Yeah.
Excellent. So Julie, here's my thought. We were talking about some of the soft skills. Here's a beautiful opportunity that IEEE presents to all of us, and that is to get involved. So what areas could we get involved with? Well, you all are a wonderful format, young professionals. We also have outreach events we have in Syracuse, we have a community that is referred to as Technology Alliance of Central New York. We're an umbrella organization for over 100 technical and professional groups. And one of the missions that we have that was started about 100 years ago by Professor Sweet was we are required to provide so many lectures, or I should say presentations, to the community at no charge. And so what we have been doing for many years is we were connected with one of the community colleges, and we would bring in the subject matter expert on a topic we thought the community would be interested in, and we would then promote it and invite people to come in. We present the topic for about 45 minutes and then open it for discussion. And usually we had light refreshments. And it was amazing to see the very different backgrounds that people had when they came into the discussion. I think you're absolutely right, Julie. All of these movements in the energy space, renewables, clean energy economy, I think that the community would love to hear about them. And I think that this group certainly has a wonderful advantage because you can take those complex problems that we talked about and you know how to communicate them in a way that allows people to understand them and to ask questions.
Thank you. Thank you. I want to just have a little follow up. I feel like the stuckness with some of this part is not at the student level. I mean, people are chomping at the bit to learn how to do microgrids and make them work and to deal with distributed energy resources and stuff like that. I feel like the stuckness might be at the regulatory and utility levels. And I mean, there are certainly problems to solve, but there are a lot of people raising their hands to try to solve them. We need to get that solving being pushed forward. And I think that's part of the reason to leverage what seems to be a demand for a clean energy economy, but also increased reliability. I mean, when you're working from, I mean, I've had this happen, I'm working from home, or being a student from home. I still have to go to my work, but and the power goes out and your stupid little UPS dies after 45 minutes and you're up a creek. So, I mean, people are hopping mad, even though they're just regular people in the neighborhood, So I feel like we have to work to unstick the bigger entities in a way and get, more progress on the problems that we need to solve to better integrate some of these other resources. I mean, maybe that's not a fair assessment, but you would know better than I.
So Julie, I'm really thrilled by your questions. I'd love to, see if we can engage you in some of the PES outreach activities, because I think you'd be wonderful. But I think your point is very timely. I think what you're seeing in many spaces is that people are asking questions because they want to understand. And what's common for us as power folks is that I think a lot of times we're not quite sure how much detail to share. So I think it's an opportunity to be able to begin those discussions and really allow people to to come to the table, whether it's a virtual session during this period, or if we have local types of sessions. Let's start to engage them and say, tell us what really is on your mind. Tell us what you're frustrated about, and then we'll create similar forums. And I think we could actually get some very productive discussions and some opportunities. You never know what you're going to find when you start talking, and you never know what solutions will occur. But I can guarantee you nothing will happen if we don't have the discussions.
Thank you so much for your response.
May I add one thing to what Mary said? So, Julie, one forum that that we have discussions of this sort is the IEEE USA Energy Policy Committee. So, if you have an interest in kind of getting involved, let me know, and I can get some introductions going on that front. But yeah, so I think you nailed it. I mean, but right now in US, it's been very refreshing. At least in the Southeast, I see that Duke Energy, if you have been paying attention, you might have seen that they have been very good with stakeholder engagement, and they just passed a net metering tariff where there was no case because everybody agreed. So it was a win-win proposition. So I mean, I think the utilities are like coming up, they are changing, um, yeah. So so that but so but now if you see the California NEM 3, the net metering, the NEM 3, they are going to have a case, and I don't know how it will move forward, but I feel there's a lot of things that are changing. But so apart from PES, IEEE USA Energy Policy team would be a really good place to do this discussion as well. And of course, we can also, all of us could continue this as well and see what we can contribute to, irrespective of what the forum is.
It's a great, if I could just add another point, Hasala, to Julie's comment, a lot of the utilities as well, Julie, are refreshing their what we call customer stakeholder engagement programs. So they're reaching out to the communities on these types of topics. So there may be an opportunity for you to be part of those discussions based on where you are. The other piece I will offer to you, I've been involved at the local level with IEEE for many years. I'm here in Syracuse, so we do have monthly meetings. The public is invited. A lot of times we're looking for speakers. When we have speakers, a lot of times they're on technical topics. Some of our grad students are actually presenting the results of the work that they're doing. But I think that the timing of your question is so important, because the next steps, the development, if we start to talk with each other, both the stakeholders, the utility people, those that work in other areas, industries, customers, we're all going to be better for it, because we'll actually discover things that maybe we hadn't thought about. So we're asking for input, and I just think this is a great time for it. So if you find it difficult, Julie, to get involved, let me know, or let Hasala know, and we can talk about it offline. We'll see what we can do.
That's great, everyone. I think we have had a really nice conversation here. I'd like to thank everyone, mainly Mary, for your time to join us today. I really enjoyed this conversation, kind of debate. We had different questions, different topics approaching. And so thank you very much for your time, Mary. We are really grateful for this session. And I think, I hope everyone just learned at least one thing or get a new point of view of this power system career path and how the distribution utilities work as well.
Yes, thank you so much, Mary, for your time.
Can we take a photo before we move
Definitely,
forward? Can we
definitely.
take one photo?
Definitely.
Well,
I also, before we close, I really would like to thank you, Hasala, to be like our great mentor here. Hasala is the main responsible to create this bridge with the main professionals, the amazing people that we just have been met in this podcast. And I also would like to thank here Paul and Ademir and Clinton. So these are the team that is make happening all the podcasts. They are on the backside, always in the camera, doing the flyers, YouTube, recording, doing the streaming. So these people here is the people that's make happening this podcast. So thank you very much, guys. And let's take a screenshot, definitely. I have the screen here. So I'll just count on 3, and then we can take the screenshot, okay? 3, 2, 1. All right, let me just save. Let's take another one. Right, let's take another one quickly. Right, 3, 2, 1. All right, perfect. Thank you very much, everyone. I hope you have a good night there. Anything,
thank you.
You have our contact, so anything, just let us know. And thank you very much again, Mary. Hope you have
Thanks,
a good
Mary.
night there.
Thank you.
Thanks, everybody. Thanks, Conrad. Thanks, Hasala. And we'll probably be talking soon.
Thank you very much.
Okay, guys, have a good night.
Perfect. Thank you very much. Bye-bye.